Hello and welcome back. So today we continue our object-oriented programming with Python. Okay. So last time we learned how to instantiate an object, a class, and then we learned how to declare a class, and then we learned how to instantiate objects of a class. So we instantiated employee 1 and employee 2 with these values. And then we understood what instance variables are, variables that are created and assigned values at the time of instantiation of the object. So when we instantiated these values were assigned to these variables. So these variables are what are called instance variables. Let's quickly write it. Instance variables. Okay. So now there are other kinds of variables in object-oriented programming we call class variables. Let's quickly write it here. Class variables are usually defined within the class and outside any function and outside the init function. Okay, so these are class variables. Okay, so the question is, when do we need class variables? But before that, let me quickly show you what's the difference between class variables and and instance variables. So let's print out employee1.date. Now what this variable is that whenever you want to find out all of the variables inside a particular object, you use the dot date. So it converts all of them into a dictionary and then prints it, and then it returns all of the variables as a dictionary. So when we print it, we print that out. So if we were to run this, we see that all of our instance variables have been printed. So whenever you want to have access to the instance variables, you use one of the instances, and then you get the dunder date variable. So we could do the same thing to employee 2, and then of course we would get the same variables, but then of course with their respective values. Okay, so now that is, and if we want to access the instance variables, we need to call the class itself, so the date on the class itself. So now let me comment this out, and then we print this, and then you will see the difference. Remember, this prints out the class variables, and when you call the .date on any instance, it prints out the instance variable. So let's print this out, and this is what we get. So we get all the class variables and class methods that we find that are inside that particular class. So some of them you might not understand, not to worry, but then you can recognize the dunder init method, our constructor method, our initializer. So this method. So from there you can tell that this is a class method, and we'll talk about class methods in our next session. So obviously it's a class method, and methods are functions. You can also find our full name method that we defined here. So that is also a class method that we defined. Alright, and then we can also find the dunder date. That is what we just called. So it's a class method, as you can tell. So it's an attribute. And by the way, it's a class variable. By the way, variables are described as attributes in Python. So, and that is what we called here. And you can also find other class variables that you don't know yet. Okay, so this is how to access class variables. Alright, now that is understood, let us proceed to creating a class variable. But before that, let us understand, when do we need class variables. So let's just say that this company that we are writing a program for, they have employees, and we have created the employee class. So maybe every year they give a 4% salary raise for their employees. Okay, so you know what, let us first write a method. Let us first define a method that applies a raise to the employee salary. So we're going to call it apply raise. And remember that every method needs to have as first argument the instance of the class. So in this case we will use self. So what this does is it raises the pay by 4%, and this is the pay here. So so we are going to apply the raise. We're going to say self.pay is equal to self.pay times, so let's say by 4%. 4. So let us come down here and just see whether this works. So let's print employee one's raise. So let me say dot pay, his pay. And after printing it out, let's raise his pay. So let's say employee one dot apply raise. And then after that we print his pay again. So employee one dot pay. If we were to run this, we'll see that the first print statement we printed it before applying the raise, and after applying the raise and printing the pay again, we see that it's increased by 4%. So it works. So now the point is that we don't want to hard code this raise in there like that. What if you have several lines of code in which you use the raise value several times, and then the company decides that it's increasing the raise from 4% to 5%? Do you have to now go in there and then start changing everything? And it's not practical to include it as an instance variable, so we make it a class variable. That means we make it a variable that belongs to the class itself. Okay, so we come here, let's just call it raise amount and say it's 4%. And so we come down here. Now when we come down here, we cannot just say raise amount. We can't, because we need to, in fact, let's just run this and see the kind of error we get. So this gives obviously lots of errors screaming at us, but when we look through the error, we see that it's a name error and it says raise amount is not defined. Raise amount is not defined. That is because we can only access the raise amount in two ways, either through the class, that is by saying employee dot raise amount, and when we run this doesn't give error, it runs very fine. Or we access it through the instance, so we say self dot raise, and then of course that gives no errors also. Okay, but there's a fundamental difference between there's a fundamental difference between accessing it using the class and using the instance. So let me just quickly show you why. So remember we use the dunder date to print out the instance variables and the class variables. Let's print them out and see. So let us print out a class variable. So we have to call the class itself and say dot date. If we were to print this out, again you can see all those class methods and variables, but then the class variable that we just created, you can also find it in there. So you can find the raise amounts right here. It is a class variable. Now it is a class variable, but it is not an instance variable. So if we come down here and print the dunder date from one of the instances, so if we say employee one dot dunder date, and we were to, let me comment this out just so it doesn't get confusing, and then we were to run this, you'll see that we only have those instance variables. The raise amount is not there. Of course, that is because it's a class variable and these are instance variables. Okay, so what this does is that, so if we were to say, let's print the raise amount from both instances. So let's say employee one dot raise amount, and then print employee two dot raise amount. Okay, And of course, if we were to print this, gives us this. Now, of course, remember we can access the raise amount using the class also. And of course, if we were to print this, this also gives this. Now watch this. If we were to reassign raise amount to a different value, so let's say we made it 5%, 1.05, you can see that it affects all of our instances. So if the company wants to increase the amount that it raises for every customer, we only need to apply that increase once, and we'll apply it to the class. And once we apply it to the class, we only apply it to the class, and once we apply it to the class, it applies to all objects of that class, including employee 1 and employee 2. Now we could have applied this raise to the increase here, or the change here. We could have applied it to one of the instances, say employee 1. But watch what happens if we applied it and then we run this. You see that it only made the raise for employee 1 alone. That is important too. So maybe the company wants to raise maybe Anthony's salary by 5%, but another person's salary by 4%. Then it can do the raise here. But the problem is, as soon as this is done, if an instance variable called raise amount has been created in employee 1, the moment you access a class variable, or try to access a class variable using an let me say this, the moment you try to reset or update a class variable using an instance, what actually happens is that it creates another variable with the same name, but this time as an instance variable. To prove that, let's reprint the employee 1.standard.date and see what happens. So I'm just going to delete these, and once we run this, watch what happens. Of course, we still have our instance variable, but then we have a new instance variable called raise amount 1.05, and this instance variable is unique to employee 1, and this happened because we run this code. So the moment we run this code, it creates a new variable into employee 1. So this one is not referring to the class variable that we put up here. No, it's not referring to this. It's automatically created another one. Okay, so you can also see that whenever we show the standard date for employee 2, employee 2, we see that employee 2 doesn't have that same instance variable. So you see that employee 2 here doesn't have raise amount, and employee 1 has raise amount. So since employee 1 doesn't have raise amount, it still depends on the class variable for its raise amount. So as you can tell, every object looks in the instance variables for its variables first. If it doesn't find a variable in there, then it looks in the class itself for its variables. If it doesn't find it in the class itself, then it looks in classes that it's inheriting from, and we'll talk about inheritance later on. And so that is the order in which objects look for their attributes. First of all, it looks in the instance variables. If it doesn't find it, then it looks inside the class variables, that is in the classes themselves, whether they have been declared. If not, then it looks in other classes that is inherited by the current class. If it doesn't find any, then of course it returns an error and tells you, look, there is no such variable. And if you are making an assignment, it creates it, such as when we did here. So when we did this, it created this raise amount. Okay, so that is the major difference between class variables and instance variables. And now let's say we let's say we want to keep track of the number of employees that we employ. All right, so we'll create another class variable called number of employees, number of emp. So we have to initialize it with 0, right? So when we do this, now in this particular situation, since we don't want any single instance, I mean, it doesn't make sense for any single instance to be able to have access to this particular variable must automatically update whenever new instances are created. So that means that we need to come here inside the constructor, our init function, and then update it. So it makes most sense to access it using the class. So employee dot num of m, and then we increase it plus equals 1. So you will find that whenever we created, so for instance here we instantiate 2. So if we were to print, so first of all let us print the variable employee dot num of employees. So before instantiating and after instantiating, if we were to print employee dot num of m, and that should give us that. So let's clean this up. So if we were to run this, you'll see that before instantiating it was 0, and after instantiating 2 objects it became 2, and it's going to keep increasing. So you'll find that it makes sense that since we are creating a variable that is going to keep track of the number of objects created, then it makes sense to make it a class variable so that we only update it whenever a new object has been initialized using the init function, and none of the objects will have unique access to it. And later on we'll learn about scoping, how to protect some variable from being accessed. So for instance, remember how we were able to assign the raise amount using employee 1? We'll be able to stop prevent that from happening. Okay, so I hope it's clear, and if it is not, you can rewatch this over and over again. If you are confused about anything, you ask your questions down below. And so next time we'll look at class methods, and so I'll see you then. And after that we'll look at inheritance. And then once we look at the core concepts in object-oriented programming, we'll do some project using it just to enhance, to give you a practical feel of object-oriented programming. Okay, so I hope you enjoyed the video. So see you next time.